Hi, and welcome to my exponents quiz. It's actually practice, and the actual quiz will be just like this. I'll have a link in the description so you can follow along with this and try them yourself. So the first one, we got to simplify this beast, and I think that I'll see that 6 is really just 6. Anything to the 0 power is 1, so I'll just say it's times 1. And then what we have to do is we have to subtract our exponents. So we have r to the negative fifth minus negative 7. Because when we divide our powers, we subtract the exponents. 6 times 1, that's just 6. And r to the negative 5 minus negative 7, that's to the second power. 6r to the second would be our final answer. Okay, let's go on to number 2. When we take a power to a power, as we are right here, you multiply these exponents here. So that would be x to the 2 times negative 4. And then I'll just do one thing at a time. So times x to the 4th. So that would be equal to x to the negative 8. And then when you multiply times x to the 4th, you actually add the exponents. So negative 8 plus 4. And that would be x to the negative 4th. Or if you want to express it as a positive exponent, that would be 1 over x to the 4th. I guess either one would be okay, because it didn't really say express this as a negative exponent or express it as a positive exponent. Because if you express it as a negative exponent, then this would be your answer. If it's express it as a positive exponent, this would be your answer. All right, let's move on to number 3, multiply these. Okay, 2 times 5. We could do 2 times 5. That's easy. That's 10. And then when you multiply your powers, like c to the second times c to the second means you add the exponents. And then d to the third times c to the fifth means that'd be d to the 3 plus 5. And we end up with 10c to the 4th, d to the 8th. And that's done. Easy and done. We got to divide these. Assume that no denominator equals 0. Yeah. No. Yeah, because you can't divide by 0. So anyway, 12 divided by 3, that's 4. And when we divide our powers, we subtract the exponents. So that'd be n to the 9 minus 2, and that would be p to the 7 minus 2. So that's 4p to the 7th. Oh, I'm sorry, not p. N. N to the 7th, and then p to the 5th. And then that's out and done and over. Write this number in scientific notation. Well, when you write something in this number right here is written in standard notation right here. That's what you're used to. Scientific notation, we start by placing a decimal to make this number between 1 and 10. And if I place the decimal right here, that would be 23. And 23 is bigger than 10. So I would have to place the decimal right here in between 2 and 3. So it would be 2.3. Okay, that's the first part. And then the second part is times 10. Okay, so I got this. So this is the format for every number in scientific notation. This is a number between 1 and 10. And then it's always times 10. And then we place a decimal here, but it actually belongs over here. So we have to count how many times? 1, 2, 3, 4, 5. We have to move it 5 times to the right. That means that would be positive 5. If I had to move this, if this was a tiny number and I had to move it 5 times to the left, then this would be negative 5 right there. So that's it right there. Boom, 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 boom. Okay. We have more. We have more coming up. And that's right over. Ooh, a tiny number. Write this in scientific notation. Well, let's place our decimal. If we place the decimal here, 0.1 is smaller than 1. And remember, we need something that's in between 1 and 10, so or starting from 1 to 10. So right there. So it's going to be 1.0 times 10, always times 10. And then I place it there, but it actually belongs right over here. So how many times do I have to move that? 1, 2, 3, 4, 5, 6, 7, 8, 9. I had to move it 9 times to the left. So it's times 10 to the negative ninth. And that is the number in scientific notation. Then we have this question here. Oh yeah. So well, what this would be is this is negative. See, this is to the first power, and a is to the first power. So this 3 has to be distributed to each item here. When you take a power to a power, you multiply those exponents. So that'd be negative 3 to the third power, and a to the third power, and then b to the 12th power, because we're multiplying those 3 times 1, 3 times 1, 3 times 4. Negative 3 to the third power, that's negative 27. And then a to the third and b to the 12th. There. Okay. And then we get into, all right, multiply this. Well, if I multiply times 10 to the negative fourth, there's a couple ways of looking at this. I mean, let's go the easy way. If it's to the negative fourth, that means I have to move this decimal 1, 2, 3, 4 times to the left. And I fill it in with zeros, 0, 0. This would be equal to 0.00128. Okay, so that, I mean, that's the easy way. Why is this the case? Well, let's just take 10 to the negative fourth, for example. That's the same thing as 1 over 10 to the positive fourth. And 10 to the positive fourth is a 1 with 1, 2, 3, 4 zeros. So what we're really looking at is 12.8 times 1 over, 10,000? Which is 12.8 divided by 10,000. And when you divide by any power of 10, you move the decimals left. I mean, that goes back to like 4th grade, pretty much. But, I mean, you punch it in your calculator, you're going to end up with that right there. Let's write this in standard form. So 5.45 times 10 to the 6th. Well, I mean, the easy way is this is telling me move the decimal 6 times to the right. Not that there's 6 zeros, but that you move the decimal 6 times to the right. So 5.45. So 5. So, oh goodness. Okay. 1, 2, 3, 4, 5. There. 1, 2, 3 times, and that would be equal to 545 with 1, 2, 3 zeros. And the question might be, well, why is it that way? Well, if you have 5.45 times 10 to the 6 is a 1 with 1, 2, 3, 4, 5, 6 zeros. What is that? That's a million. 5.45 times a million would be 5 million. I'm pausing for a moment because I'm realizing, wait a minute. Wait, did I move that 6 times? Hold on. 1, 2, 3, 4, 5. Ooh, okay. Whew. 6. 6. So I need to erase this answer right here. Yeah, change that up a little bit because I didn't move it 6 times. Ooh, I got lucky on that. 5, 4, 5, and then 1, 2, 1, 2, 3, 4. That'd be 5,450,000. Okay, that is standard form right there. We'll simplify 6 to the negative second. That's the same thing as 1 over 6 to the positive second, which is 1 over 36. And negative 2 to the second, well, what that means is negative 2 times negative 2. And that is equal to positive 4. And let's see. We need number 12. 12. How many of the following statements are true? Without a calculator, too. Well, the square root of 2 plus 5.0. Well, I mean, what times itself is 2? 1 point. It's going to be between 1 and 2. Call it, you can call it 1.5. It's too high. 1.5 is too high. But this right here, let's see, I'm going to try to take a picture of this and bring it over. So I think this, I mean, at most, if this was 1.5 plus 5.1, what is that? At highest, that's 6.6. So, okay, 6.6. Then what would this be right here? 5.5 times 3.14, 5 times 3 even. Don't even call it 3.14. 5 times 3 is 15. 15 minus 7.4. Ooh, this could get a little close, couldn't it? 15 minus 7.4. I can't think off the top of my head. 6? 6.4? Ooh. Oh, this is a little tight, isn't it? Okay. All right. So I'm going to have to get a little bit precise here. 3.14 times 5 is 0, 2. That's 7, and that's 15.70 minus 7.4 is 302. No, it's not 12. Oh my God. Why did I write 12? It's silly. 15 minus 7 is 8. It's 8.30. So, yeah, that's true. And I even overestimated that. Anyway, go ahead. Go ahead. Why did I say go ahead? Let's do more here. 8 6. 8 6. That's 1 and 2 6. That's 1 and 1/3. That's 8 6. Plus the square root of 36 is 6. Is that greater than 5 plus pi? That's 5 plus 3.14, right? 5 plus 3.14. That'd be 8.14. 8.14. 1/3 is the same thing as 1.3 repeating. So 1.3. This all together is 7.3 repeating. And so that's not true. So 2 is false. And then square root of, or 37 minus the square root of 30. Okay, well, the square root of 25 is 5, and the square root of 36 is 6, and 30 is closer to 36. No, it's closer to 25. So this calls 5.4. 37 minus 5.4 ish. Is that greater than 10 times 3.14? Well, 10 times 3.14 is 31.4. That's easy. And 37, oh God, I can't even think right now. 37 minus 5.4 is 0, is 6, 1, 31. Ooh, that's tight. That's really tight. I'm gonna say yes. Let's go with true on this one. So, how many of the following statements are true? I would say C. 2 of them are true. I have the answer down here. It's all the way down here. That's number 12. Number 12. Hey! I was right. Oh, I was off too. I was off a little bit. I was overestimating on that one, but I could see here it's 7.3. Oh no. Oh no. No, I was okay with that. That's the false. Yeah, see, yeah, true. And then that one, ooh, yeah, I was kind of off slightly. Oh, no, oh, 5.4. No, I was pretty good with that. And then, yeah, 3.14. Yeah, yeah, my estimations were pretty good. I don't know why they say that that's okay. That's not quite right. That's 1.14, not 2. I know it's 1.14. I even overestimated at 1.5 uh, to even give it more spice, but it still didn't go. And maybe that's a problem with my algorithm. I'm not quite sure. I'll have to check into that. Okay, so we have this one. Which of the following list of terms could describe a person's age? Well, if we know this right here, the real number system. I'll slide it over here. A person's age is going to be an integer, right? It's not. It's going to be a whole number. It's going to be a natural number. No, it's going to be a whole number because it can start with 0. Remember, these start with 0, 0, 1, 2, 3, 4, 5, 6. So it's whole numbers right here. So it would be, well, an integer and a whole number, I guess. Yeah, it would be a whole number. And if it's a whole number, then it's a integer. So I would call it a whole number right here. And let's see what I said down here. Because integer could be a negative number. So I definitely know it's a whole number. But the fact that integer is in here is messing with me a little bit. So let's go with 13 here. Oh, it's A. Yeah, it's none of them. It's a whole number. So the fact that it said integer means it could have been a negative number. So that's not it. So it's definitely has to be none of these. Yeah, I would have loved for it to have been this one, but integers. Nobody can be negative 8 years old. And rational numbers are fractions, you know, and negative fractions. So that's not going to work. And no one's going to be an irrational number for an age. So, number 14. Which of the following are irrational numbers? Well, this right here, that is a fraction of integers. So definitely rational. The square root of 49 is 7. That's rational. This is 48 over 99 because when you have a bar like that and there's two numbers, you put it over 99. Those are all rational. Oh, and this is negative 1 and 296 over 1,000. That's rational. The fact that you can make these fractions, you know, 7 is the same thing as 7 over 1, then yeah, all day, that's going to be a rational number. So what is the answer? The answer is B. Yeah, I don't know what the square root of 207 is. It has no nice square root to it. And pi, famous irrational number. And I think that's all I got to say with that. So thanks for watching. Hopefully this was helpful.